I won! Okay, so we got our g function. What does it do? Well, when you plug stuff into this g function, you're going to put that stuff on the bottom of a fraction and square it, okay? Okay. So this first one, it says you're going to use a g function and you're just going to plug in the x. Isn't that the same thing as this right here? See, it says that. Yeah, you're right, it is. So you just have to write it, 1 over x squared. And then you have other stuff happening. Then you have this guy over here. It says plug in a 3 to the g function. So I'm going to go over to my g function. I'm going to plug in a 3. So I'm going to go take that 3 and I'm going to square it on the bottom of the fraction because that's what it says to do. It says take that 3 and plug it into the bottom. Okay, so then we have x on the bottom, x minus 3. Maybe that wasn't what you were stuck on, but let's continue on, shall we? We shall. Now this is a 9, right? Yes? Okay. And if I wanted to simplify this nasty looking thing, the first thing that you would want to do is look at the top and look at the bottom and ask yourself, can I simplify those? And I can simplify the top, I can't simplify the bottom. I simplify the top by finding common denominators and then adding them together. So for this one, I would multiply the top and the bottom by 9. So we have a denominator of 9x squared. What would I multiply the top and bottom by on this one? Tell your neighbors, go. Yeah, that's good, x squared. So we got x squared here and x squared here, and so I'm subtracting that, so I'm going to show that by putting that minus there because I was really bad with negatives when I was in high school. 9 minus x squared on top, and on the bottom we have a 9x squared, and that's all on top of x minus 3. Wow. It looks a little better, but not that much better because I hate seeing fractions inside of a fraction. That's hideous. Do you guys know how to kill fractions? You see, I get my eraser and then no. No. You can't do that. We have to do it. We have to kill them with math. Okay, so what we're gonna do is we're going to multiply the top and the bottom of this big fraction by something. What is it gonna be? 9x squared. Because look. I put it over 1 and these get canceled out. Yes. Oh, it's so beautiful.
I thought you were going to say that.
I don't know what you're talking about.
Because this is your video.
Yes, this is. You're right. Okay, 9x. Oh, I forgot my squared.
Okay, I was like,
Yeah, you can't just remove the squared. Yeah. Now you got this. All right. Now I see this x minus 3. I don't know if you guys see it, but I can factor this right here, and there's a good chance I could cancel something out. Be x minus 3 3 minus x and 3 plus x. And this guy and this guy are almost identical. The problem is this one the x is negative and this one the 3 is negative. So I got to take a negative out of one of these factors. It don't matter which one. I can take it out of this one. That sounds good. And now they're exactly the same. This guy's the same as this guy. Yeah? Yes. All right, we can kill him. You guys want to kill him?
yes.
Kill him! Ah! Oh! Okay. Why? Okay, we have negative. You guys are like, yeah, why are you screaming? Okay, we normally like the x in front of the 3, so I just switched that. I mean, that's commutative property. So we have 9x squared at the bottom, and that's it. That's what you got. This is your answer for this one. Okay, now, some of you guys don't like what I just did right here with this 9x on the top and the bottom. You could think about this a different way, and this is how you can think about it. You can think about this, which is 9 minus x squared divided by 9x squared, divided by, because that's what this big bar means right here, it means division, divided by x minus 3. Do you guys know how to divide with fractions? Yeah, you multiply by reciprocal. So I'm going to change this to multiply, and I'm going to do the reciprocal of this, and then I multiply. And so you can see that essentially I'm going to get the same thing as what I got right here, and then I'd still have to simplify and get that. So it's just a different way to think about it, but it's exactly the same actually.